Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much for your attendance. Before we start our studying today, let us pray together. Bismillahirrahmanirrahim. Rabbi syrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilman warzuqni fahman. Okay, good afternoon everybody. Today we will discuss our discussion in module statistic and data analysis under the topic of the distribution of probability. And as we discussed last week, we have this these beautiful words. Lucky people are people who are good at reading opportunities. So it is very interesting for us to study about a probability. And today we will see that we can also analyze the distribution of a probability. Okay, as our introduction today, I would like to speak about hypothesis. You know that as a candidate of scientist, we will have experience in future in making hypothesis. Hypothesis is a temporary answer for our research question. And to get the conclusion at the end, after we analyze the data that we have, we can do the hypothesis test. And then what is hypothesis test? It is also about probability. Hypothesis, in a hypothesis test, we will have two possibilities between acceptation or rejection of hypothesis null. So you see here, if I can draw for you. Okay, as we learned last week, for example, you have 0 for rejection, and then at the opposite you have 1 as exception. So then you have two possibilities between acceptation and rejection of hypothesis null. And then if we ask how big is the probability of acceptation? So the probability of acceptation, for example, A here, for our hypothesis is 1/2, because we have two events, that is acceptation and rejection. And the probability of acceptation is then 1/2. And the same, in the opposite, we have also the probability of rejection of hypothesis null. For example, I put here PR, R for rejection. Again, you will have 1/2. Okay, then if you want to sum up, the total of probability should be always 1. Okay, it is about a hypothesis. So then we can have understanding together that in hypothesis test, we have also the theory of probability. And in data analysis, using statistic, you will also meet a p-value. What is p-value? So p is stand for probability, and value is a value. And the possibility criteria then is known as p-value, or we can say it is a level of significance. And in practice, you will compare this p-value to alpha value. For example, we have alpha 5% or 0.05. Then we can say that there is about 5% chance that we will conclude wrongly. Or we can also say in the other hand that we have about 95% chance that we will conclude correctly. Okay? So it is the correlation between p-value and alpha by how to say comparison these two value, we can have a conclusion about the result of our analysis. And also for the data distribution, we will have a normal distribution, F distribution, or T student distribution, etc. We will have some other form of distribution. Okay, now let us see about the probability function. Yeah? In this case, we use a dice matrix. Yeah, you know a dice is a dice. Yeah, a dice you will have like a cube. Yeah, I don't know if I can draw for you like this, for example. Okay, and actually we have like 6 surveys, and each surveys of dice will present a different value. 1, 3, for example, 2, yeah? And the rest we have also 4, 5, and 6. So we have altogether six possibilities, yeah? Or 6 events. So if you have play about using 2 dice, yeah? 2 dices, then we can build this matrix. You can see from this table, yeah? Now we are build a matrix from 6 possibilities of a dice, yeah? Because we have now 2 dices, then what we can have from a ruling of a dice, yeah? You will have here, you can see 6 times 6, you will have about 36 events, yeah? Okay, you can see here 6 times 6, yeah? 6 times 6, you will have the total of 36 events or possibilities. The first one, for example, you can see here from the matrix 1 uh, and 1, yeah? For example, the first dice you get 1, and the second dice again you get 1. So you can see here that the possibility of having 2 times 1 value is 1 times here. So then we can also write or calculate the possibilities, yeah? Like the probability of having 1.1 from this case is about only 1, yeah? Only 1 here, only 1. So 1 over
36.
yes, 36. Yes, very simple. It's good, yeah, thank you. And also I can give you a question, for example, how much the possibility or the probability of having this 6 and 6? How much?
1/36.
Good. Yeah. Okay. So uh the way is like that, very, very easy. Now we can continue. Okay, look here. The sum up of total probability is 1. I will show you later. We will use Excel sheet, yeah, to prove this. And the probability function should not be in negative. It is also something fair, yeah? That if yeah, if there is a negative uh, possibility or probability, that is not fair. For example, yeah, what is negative? How we can give the example of negative possibility? For example, you enter the Department of Agricultural Engineering. So you will have like one is the possibility to graduate. The second one is the possibility to not graduate. So you have that. That is fair. But if you have like the possibility to negative, yeah, to be negative, uh, impossible to graduate, uh, it looks like not fair. Okay, I hope you get that. So the probability function should not be in negative. So no negative value for the probability. Always positive. Maybe in that way also, Allah said that you should think positively, yeah? Because Allah give us always probability or opportunity. So never think in negative. Be positive, yeah?
Yes,
And
ma'am.
good. For this, you see, we will have a new term PDF. The PDF is stand for probability density function. Probability density function. And then we will use like F in small letter, function of its letter. We will use this. F is for the PDF. Okay. Okay. Now, what I told you about this matrix, we can say it in this by using this sentence. You see, if x is in capital X, yeah, is a discrete random variable of the total number of possible dice numbers that can appear. So what we make in matrix, then uh, what is X? Who is X? So you can write down here X is uh, in bracket who is X. You can see here you have 1 and 1. So 1 plus 1 is 2. So you have 2. And then you have also 2, the possibility of having 2 and 1. So then the total of 2 and 1, 1 and 2 is 3. Until you have the biggest one is 6 and 6, you have 12. Eh? So here is the member of X. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You have 11 members. In this case, you can make this sentence to describe the matrix that we built already. Okay, now we continue to see how is the probability function. Okay, here is the PDF, or the f of x curve from this matrix. How we can get this? I will open for you. I will open for you another sheet. Can you see it? Yeah.
Yes, ma'am.
Okay. Now you see, I built this Excel for you. Here we have the total events or possibility from 2 dices is 36. And then we have X, X, and we can put the member of X. Start from 2, 3. So I can pull it. Okay. So I have more here. Okay. And now, remember what we have? We have how many times the total number of dice appear to be 2? If you remember, how many times?
1, ma'am. 1.
1. Okay, I put 1 here. And then how many times 3?
2. 2.
3, 4, 5, and 6, and we go down to be 5, 4, 3, 2, and 1. Okay, this here we have already. And so what is the probability of X then? So we have, if you remember, we have I don't know if I can use this here. If you remember, the probability of X is equals to the frequency of X over the total events we have. So here we have the total is 36, and here we have the frequency from column B. So I can make like this here equals to 1 over 36. And for 36, we have in A2. And to make this add dollar, to make this as a constant, yeah. Okay, then just pull it. You get this, okay? And we can also reduce the decimal as we want or not. Yeah, it is not a problem, okay? And after we have this, we can make a chart. Just insert a chart. Here you can choose XY scatter. I think insert chart here. Sorry, here. Oh, I can make this. Sorry. Okay, later. Okay. This one, XY scatter. Okay. It is very easy. Just click your right side of mouse, and then select data. So you add this PDF and put as X value this X, and then as Y value the probability of X. Okay, then say okay. Okay again. So see, you will have the PDF, yeah? So here we are. Go back to our PowerPoint presentation. Okay, now you have this PDF or the function of X from your probability density function. So you analyze the probability of rolling 2 dice, and you get altogether 36 possibilities, and then you determine the member of X, and you get 2 to 12. You have 11 members, and then you calculate also the possibility of each X I, and then you put it in chart. You will produce this chart. The chart is look like a very fit with a normal distribution, because if you give this, for example, a line, if you make a line in the middle of the chart, you can have like a symmetries between the left and the right side from you. You can see, so it is a very good chart. Okay, now we continue. Here is you have you can see here from this slide I put for you the calculation of the possibility of X. You can follow this later, but we just do it very fast by using Excel. You can do this later. And the result of this, you plot already to be the PDF. Okay, now the next one, we have a cumulative distribution. And for this cumulative distribution function, we have a new term. It is called CDF. And what is CDF? So CDF is, you will use capital F, yeah? Please remember, capital F. But we use a small f for PDF and a capital F for CDF, yeah? So here we are. And how to read this, yeah? F capital of X, yeah? Or the cumulative of X equals to the probability of X that is less than X, yeah? Less equal than X equals to the sigma of value, yeah? That is less than X of the probability of the lower value than X, yeah? The lower value and also the same as X, yeah? So go here, you can see, for example, you want to know the cumulative, yeah? Distribution function of 2. You know, the first member of our X is 2. And see here, equals to sigma of X that is less or equals than 2 of probability of X. And here you have X that is less or equals than 2 is only 1. That is the probability of 2. And you have previously that P of 2 equals to 1 over 36. Okay, here's the first case. And now let's go to see the cumulative distribution function for f of 3. Yeah? You can see here that then equals to sigma x less equals than 3 of p of x. Yeah? And here you can see that you have more member, not only p2 but also p3. So then you should sum up together the probability of 2 plus the probability of 3. And then you will have a bigger result than before, from 1 to over 36 to be 3 over 36, etc. And what happened when you reach F12? Somebody can guess? How much is F12? The CDF or cumulative distribution function for F12? Any idea? For F2, you have 1 over 36. For F3, you have P2 plus P3, and then you have 3 over 36. For F4, you have P2 plus P3 plus P4. Okay, so my question is, what is the value for F12 in our case? What is the value for F12? Okay. Okay, let's go back to our Excel. Okay, here I can add for you. I will remove this first. Here this is f of x, yeah? And now we want to have f capital of x. This is cumulative, yeah? F capital of X. I put once more. Okay, how is it? So, for this is P2, yeah? And how about for F cumulative 3? It is, should be P3 plus P2 plus, okay? So then I can just pull it. How much here? F12? Somebody can guess it? How much? If I pull to F12, F of 12. Look. How much?
1, ma'am.
1. Okay, good. So remember, the total of probability should be 1. So I sum up this. Do we get 1? Yes, we get 1. You see here, eh? We get 1. And also, we have 1 for the cumulative, the highest cumulative, eh? Okay, now we can draw the next chart, yeah? I just copy this, eh? Okay, just copy, but I can change this to be CDF. And then I just like select the data, PDF, edit, I change this to be CDF, and then I change just the X, Y value, yeah? Okay, then yes, okay, okay. Look what we have here. Okay, here we have our new chart for CDF. You can see here we have, can see the increasing value from the beginning until the maximum of 1. Because the total probability or possibility we have is always 1. So in CDF, you can see that the maximum value of a CDF should be 1. Okay, that is the idea. Okay, now we can continue. Here, I put for you together the PDF and the CDF curve. You can see here. It follow the a normal distribution, like a mountain, or A shape. You can see. And what we have, the total area below this curve should be 1. And in CDF, you can see that the maximum value of CDF is also 1. Okay. Okay, and now we continue about understanding the 2 parameters that is very important. The first one is mean of a distribution. So what is mean? Mean is a parameters that represent measures of centralization. So if you go to the centralization, that mean in the middle or in the center of a point, that is a mean of a distribution. And here we make a notation for mean as mu. Mu of x equals to sigma e equals to 1 until n of xi multiplied by the probability of xi. And then we have the second parameters that represent measures of dispersion. It is called variance. Variance of a distribution We can calculate by using this formula. Variance is tau, tau x squared equals to sigma e equals to 1 until n from the difference between xi and mu x and square of multiply by the probability of xi. Okay, so please remember we have two parameters. The one is that represent measures of centralization, that is mean. The second one is the parameters that represent measures of dispersion. It is called variance. And for each parameter, we have different formula. So I will show you now. We go back to our Excel sheet. See here, we will calculate the first value we need, that is xi multiplied by probability of x. So what it is? So you have to multiply by p of x. Okay. Then you can get this here. Okay. Then we calculate the sum of this. You get here 7. What is the meaning? Then your mean value for this distribution this time is 7. So let us look to the chart. We have here chart. Where is the mean? Can you see this chart? I will change this. The format axis. I will make it like here. I will change this to be 1. To be 1. Okay. Okay. Look it. What you can see here when I make this, I can make it. Okay. What you can see here from our PDF. Where is 7? I will show you. Here we have 7. 7. I will make this bigger. And also with color, for example, red. Here is we have 7. And from our calculation, we get that the mean of our distribution is the mean. We have mu x equals to sigma e equals to 1 until n from xi multiplied by the probability of xi. Okay, sorry for my writing with my bad writing with my mouse. So we have here already. We have here already xi multiplied by probability of x, and then we sum up this and we get 7. Look to the chart, you see directly what is 7. You have actually 7 is the peak of the chart. And also it is in the middle, exactly in the center of the PDF curve. So it is the meaning of means, the central value you have. Okay, now we continue to look for the variance. Variance, you need this. At first, you need okay, you can use this one is xi. Here you have I minus mu. Mu is 7. then you need to put bracket.
Ako masih berproses. Datang tiba-tiba si kopur udah punya banyak duit.
Oh, gitu ya.
Datang ke rumah ngelamar. Dikasih 20 mayam. Mana saya?
Iya. Aku tanya dulu sama kamu ngomong juga. Weh, enggak dong. How you can speak like that, ya? Okay, then just pull it, ya. Oh, but remember to add dollar, add means value, ya. So then you can pull it. Okay, you get this. And then you need the next is this multiply by P of X. Yeah. Okay, you need this, yeah. Okay, now you have this multiply by this, okay. Then just pull it and also do sum, sum up. Okay, you get here the variance of your data in this case is 5.83. So you can look here where you have 5.83. Maybe somewhere here. Somewhere here close to 6, yeah? Close to 6. Here. Okay. Sorry. The variance is the dispersion of data, yeah, from the mean. So we can say that you have the variance between 7, yeah, plus minus 5.83. So 7, if you have 7 plus, yeah, 7 plus, you get 12. And then if you have 7 minus, okay, so you have the variance from 1.1 to 12.8, yeah? 1.1, you have here 2, 1.1, and the others, you have like here, okay? That is the dispersion of data, So the ring, Okay, we go back to our slide presentation. Here. Okay. So we already calculate the mean of our distribution and also the variance of our distribution. And we get from our calculation that the mu x we have for our case is 7. And then we have also the variance x. Variance is tau square is 5.83, okay? That is what we get. And here also I have a slides that you can again calculate. You can do manually or you can also use your Excel sheet for practice. You can do this. Okay, now we continue to discuss how is we meet the continuous problems, not the classic one. Still, we can make our PDF. Yes, yeah. PDF is the probability. PDF is the probability per unit interval, yeah, of the value of the random variable.
Kan berjilbab.
Okay, let us continue, yeah. Again, yeah, PDF, we will make it as a small f, yeah, of x, probability density function, and it is the probability per unit interval of the value of the random variable, eh? And PDF should be positive or bigger equals to 0, eh? And since we have the curve of PDF to be like this, and we know also that the total probability is always 1, we can also make a new statement, yeah? The integral of PDF equals also to 1. So what is the integral of PDF? We learn, if you remember your calculus, yeah, module last semester, we can find the area under a curve by using the integral procedure. And by this mean also, then we can make this new statement, the integral of PDF equals to 1, because the total of probability is always 1. Yeah? Or, on the other hand, we can say total area under the curve of x is 1, because the total of probability is always 1. So that is the idea. Yeah? 1, or we can say that 100%. 100% is 1 over 100, then the same as 1. Okay, then you see from this, for example, you make two line, A and B, A as a lower boundary and B as upper boundary. Then you can, how to say, shadow this area. Then you can calculate the area of this shadow. How is it? Just use it. The probability of x, that is less equals to b, but bigger equals to a, equals to integral a to b from f x dx, f of x dx. So that is the idea of using integral to find the how to say, the total area under the curve. Okay. Okay, now I want to discuss with you one examples question. For example, here we have the problem is in a pharmaceutical production process. The oven can be used in 5-minute intervals. So if there is a delay, the chemicals must wait until the oven is ready to be used again. If x is a continuous random variable that represents the waiting time of the chemicals, is x, that is determined by x less equals to 5, but bigger equals to 0, determine the probability density function 4x. So how we can answer this such question? Okay, look here. Because it is said that x is how to say less equals to 5. Yeah. So we have here we have x is less than equals to 5, but bigger equals to 0. Then I'm making this, yeah. I'm making this chart from 0, 1, 2, 3, 4, 5. Okay. Then what we can see here, we have like 1 over 5, yeah? 1 over 5, 1 over 5, 1 over 5, 1. The idea is that. So altogether will be 5 over 5 or equals to 1. So we meet the criteria from this, yeah? From this idea, we meet the criteria. Then we learn that, oh, the f of x should be 1 over 5. And what is 1 over 5? Yeah? 1 over 5 is you can multiply by 2, for example. We come to 2 over 10. And 2 over 10, you can put it like this. 0, 0.2. Eh? So here is, I put this yellow line at f of x. You know also f of x is y. Eh? F of x of 0.2. Okay, that is the idea. Eh? Okay, now after we solve the problems, we can say that the PDF function, the f of x of the problem is 1 over 5. Okay. Now we can try to find these second problems. What is the probability of x less than 3, less equals to 3, bigger equals to 1? Okay, just use the formula we have. So we have the limit from 1 to 3 of f of x dx, and we have fx, our f of x is 1 over 5. So then we have 1 over 5 d of x dx. And then we have here 1 over 5 integral 1 to 3 of dx and 1 over 5 x, yeah, from 1 to 3. And you can change then x to be 1 over 5 from 3 minus 2. 1, minus 1. 3 minus 1 is 2. 2 times to 1 over 5 become to 2 over 5. That is the answer you get here. And you can also try to find the solution by using this figure. From the same figure, you know already we are asking about the probability between 1 and 3. So then just try to shadow the area between 1 and 3. And what you get here, you can see, already you spend 2 times 1 over 5. Look at 2 times 1 over 5. So then it is also equals to 2 over 5. Okay, so you can also solve the problems not using integral but using the visualization. So it works also. But To do integral is more efficient, especially if you meet complicated problems. Sometimes we need time to draw something. So you can choose this integral procedure. And also you can look to this question. What is the probability of x that is bigger equals to 3.5? Yeah. So please look by yourself from these steps and then compare to what you can find from drawing, from imagination here. Okay, I hope you can do it by yourself. Okay, now CDF. We can also see CDF function, cumulative distribution function in the continue case. Yeah. And here, I put also for you the CDF and PDF function together. So you can see here the this one is the PDF and this one is the CDF. Okay. And always remember this, the PDF is using small letter of F and the CDF use the capital letter of F. Okay, so give attention to this area. So for example, you give the boundary of B and C, and you shadow it, B and C. So how then you can calculate the area of between B and C? Look here, you have here like the cumulative C. Cumulative C, that's mean here. Oh, minus cumulative B. So if you use, for example, I make this cumulative. At first, I will make you cumulative B, I make it red, cumulative B. This area, the red area, cumulative B, And then now, I give you the cumulative C, this one. Okay, can you see? Then, the area here is actually the cumulative C minus cumulative B. So you will have this, the rest of the area. Here you can see that how is the relation between CDF and PDF. And now we can make it in a formula. The cumulative x of x equals to the probability of x that is less than x equals to the integral of fx dx. And of course, then we will determine the upper limit and also the lower limit according to the case. And then in the case you want to answer this problem, what is the probability of x that is less than equals than C, but bigger or equals than B? So you can make this equals to integral f(x) dx from the beginning, because you don't know, then you said like from infinity to C, because you don't know here, infinity in this side. Before the termination, you can say here is infinity. You don't know what value here. Infinity until C, f(x) dx minus infinity until B, f(x) dx. And this integral of infinity until C, f(x) dx is f cumulative C. And the integral infinity until B, fx dx is F cumulative B. So then you have this, you have this approach, and it's very easy after you understand this to apply this during solving the problems. Okay. Okay, now I have the next examples. Yeah. For example, the PDF of the magnitude of the dynamic load X on a bridge is expressed as. How is the function? You have here the f of x equals to 1 over x plus 3 over x multiplied by x if x less than equals than 2 but bigger equals than 0, and f of x would be 0 for others value. Okay, so it is the rule we have. So we can answer directly that the f of x, the f cumulative of x is equals to integrals of infinity to x fx dx. And then we know that this infinity, the lower value is a 0. We can make it to be 0. We can change it until x, yeah? And we have this, yeah? To answer this question, I think I missed some statement. Actually, find the PDF magnitude at this conditional. If x less than equals than 2 or bigger or equals than 0, so then you just choose this in that condition. So then f of x becomes the integral of 1 over x plus 3 over x multiplied by x dx. And then we have at the end 1 over x plus 3 over 16 x squared. Okay, I think you can follow this. You can try. And what is, if the question is, what is the CDF, CDF for x equals to 5. Then remember that for others value rather than this, so the f of x would be a 0. Okay. I will add some information that I miss here to answer this question. Okay, we continue for the rest of our slide. Here, just give your attention, and then follow this. Can you find then the answer like this, Just follow. Here, it is asked that the condition you have is from 1 to 1.5 kilonewton. So like I can make for you this time, try to find this one, x. The x is less than equals to 1.5 and bigger equals to 1. So try to find the probability between this condition. Okay, then it is very easy because you already have the function, and just put the value. Okay, and to help you understand this, you can give attention also to the chart I put for you from the book, and just follow this. Okay, and then again, we will have like continue problems, yeah. And previously, we know already that the mean of a distribution can represent measures of centralization, and also the variance can represent measures of dispersion. Yeah? In the case of continuum, you need to see the adaptation of formula. What is it? Here, for example, for the mean of distribution in continuum case, we use also integral a to b from x multiplied by fx dx. Yeah? And for the variance, you see here, we have also the same formula like previously, but we just change the sigma here to be integral. Here we have then integral from xi minus mu x and square multiplied by fx dx. So then we can also determine the mean and variance of our distribution in the continuum case. And now about histograms, yeah. You know, histogram is also one kind of types of chart, yeah, to describe our data. But here we learn also that the area of a histogram is represents also the value of the probability function. How? It works like this. If you calculate the height of the bar following this formula, the height from x that is less equals to x upper boundary bigger or equals to x lower boundary equals to the probability of x at that condition, yeah, over the difference of the boundary. So if you are using this to determine the height of your bar, then the area of histogram is the value of probability function. That is the idea. And then the last is about expected value, E of x. Yeah? So it is very easy because expected value is the mean of variable x. So you know, we always makes the mean value as the most important parameters from our data. The mean is also like give us or represent us the condition, the real condition of the subject. And now we learn another value that the mean is also the expected value. Okay. And by this, we will see that the expected value in the classic case, we follow the mean formula in classic case, and also the expected value for the continuum case, we follow also the formula of mean in continuum case. Yeah. So here we use integral. In this case, we use sigma. Okay, that is the difference. You have also, I give also for you the link that you can follow this. Maybe you can find some more explanation, or you can have a next experience in statistics. You can also calculating the variance from the expected value. And following this complicated formula, it is not so hard, but just look to the bracket. So the variance x, the variance of x equals to the expected of x squared minus the expected of x square, something like that. Okay, so I think I finished my presentation. If you have some question, you can just raise your hand. I will give you a chance for asking, okay? Please. Any question from your side? So all of you attend, yeah? 17%, yeah?
And I want to ask a question.
Yeah, please. Thank you.
Honestly, I want to ask something that's not too related with our topic today, which is probability. I want to ask about the integral. Beforehand, you saw us the formula of probability, and there is so much integral in that I little confused about. I want to ask why integral, like integral is in anywhere in probability. I don't really understand how can integral can solve probability. Like as we know, probability is depends on someone's luck, and integral is logic. I don't really understand how can integral can solve probability with that. Can you can you um how to say that? Explain that to me, please, ma'am.
Okay, I will try.
Oh,
Maybe somebody else want to add to the
thank you,
question?
ma'am.
Yeah, thank you. What is your name?
My name,
Berliana. What is
no,
your name?
I'm Kispia Kadrin.
Uh, Kisvia. Okay, Kisvia. Okay, Kisvia. Thank you, Kisvia, for your question. Any comment from friends? Okay, look, maybe I hope I can answer the question, yeah, from Kisvia. Okay, now we are talking about probability. So then from this case of probability, we can have a set of data. For example, we play just now with two dice, two dice, and then you get the matrix of 36 events, 36 events, and then you can like determine the x value from 2, 3, until we have 12, Okay, if you remember it, can you follow? And then we can determine the P of x. P of xi, we can determine each of them. And you know here that we already know sigma I equals to 1 until n of P, xi is always 1, right? And then we also come to produce a PDF. So remember, this is the story. What is PDF? You have a curve like this, look like this, the PDF. The probability density function from our data that we just discussed. And then what happened? We have here the idea of that the total probability is always 1. And then if we want to calculate the total area under the curve is also 1. Okay, that is the idea. Okay, so the integral of fx, why fx? Because it is PDF. And PDF, we are using the notation of f of x. Remember, for PDF, always we can put it as f of x. Not for CDF. For CDF, we will make it f capital of x. Okay, so you have fx dx. Okay, and you will have 1 from, for example, you have here a, you have here b, yeah. So the integral a to b fx dx would be 1. This is okay. Then why integral? For this, you can help yourself by open back your notes from your calculus class. Yeah, how to calculate the area under the curves. How to measures or to measure area under the curve. Do you remember this? I teach you last semester or last year. How to measure the area under the curve? If you have like this curve
Remember
and
that honestly,
uh,
but I
yeah,
remember we already learned that before in the last
uh,
semester.
yeah. If you know the function f of x and you know the limits, so the area L, for example, or you can make like A area should be the integral of A to B fx dx. So that is the idea. Then why in probability we are talking about and using integral to solve the problem? Because we just learned that theory. The integral can be used to calculate the area under the curve accurately and fastly. You can like measure manually, yeah, conventionally, or how, for example, you split this area in a very small rectangles. Then you calculate the length and the width, and then you make a summation. You add, you can find the solution, but it takes too long, and also you will have like error. For example, in some area you have the larger than uh, above the curve. In some you have like lower, so you produce error during calculating. Sometimes you have the like this, sometimes you have like this, yeah, because like this, yeah. So sometimes you lose here, you lose here, uh, then the calculation is not accurate. But using integral, you will have accurate calculation. I think I hope that you can understand it. Why then we also have integral in discussion probability, since we can produce the curve. So the curve of what? Of our data. And today we make the data from the case of probability. Next week we will discuss also about sampling. We can also have a new data, not from the probability, but from the real experiment. So that is. So statistics teach you like many things, yeah, related to the event that happen not by your force, and also teach you about how to manage event that you create in a treatment, maybe in experiment you are making the events, but in probability, yeah, you learn from the what happened, not because of your design, yeah. Okay, and then it is amazing for me, yeah. I hope also that you always can use our science to improve your belief, yeah, to improve your belief in God, yeah. because it is very interesting. You learn from the natures about this, and also you can have the same in your own experiment. So nothing's contradictive, yeah. So it is very interesting and amazing. Actually, in your experience, experiments, you follow what nature teach you. Some people they don't believe to God. They learn from nature, and for me, I think I believe that Allah teach us by nature, not the nature teach us, yeah, but Allah is the creators for universe. So then we learn from what Allah created for us, and also then as a scientist we make our own experiment. Eh? So it is very interesting then to discuss about the data from many evidence, natural evidence or from your own experiments. Yeah, that is I think. I hope yeah we can still discuss in our groups. Yeah, I don't know your capacity of listening today. Uh, my plan is to talk less. Okay. 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 Thank you, Karina, and for all for your attendance. And to support us again, I will give you Kahoot, yeah. We will try, yeah. Kahoot. Okay. This is special for you. Kahoot in English. Please join. Okay, our pin is 859226, yeah. Okay, thank you very much, yeah, for your attention today. And for someone unlucky, we will try to repeat our Kahoot. But for this, you need to learn by yourself to remind me. Yeah, you can make this other time. Okay, then I wish you improve your spirit for studying. Yeah, be strong. Yeah, give this as your challenge. Yeah, put this international class as your challenge to improve your English, and it is very important to uh, to be able speaking English, and I wish you can continue your studying in future in other countries abroad. Go abroad for your better education. Okay, thank you very much. I'll see you again. Forgive me for my mistake during teaching. Oke, billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
See you
Wabarakatuh.
again.